All right. Yeah, so hello everyone, good morning, and welcome to our talk about migrating a large AEM project to TouchUI. And before we start, a quick introduction. So my name is Gregor Zurowski. I work for MBIO since early 2016. I started to work on building a cloud-native platform for MBIO as a platform as a service for our microservices architecture, and recently shifted gears. And since this year, I'm focusing on our CMS implementation, which is based on Adobe AEM. I'm also an Apache committer and PMC member for Apache Camel, if you know that framework. And if time allows, I'm also work as a technical editor for Manning publication for various technical titles.
Hello, everyone. Good morning. My name is António Ribeiro, and I joined Mercedes-Benz I/O Lisbon Hub last year, June of 2017. And since the beginning of this year, I belong to Gregor's team, where I'm helping in the development of our AEM solution. On my spare time, and since I'm an avid and fond of Stack Overflow, I try to contribute the most to Stack Overflow, and pretty much is it.
All right. Before we, oh, it doesn't work yet?
Yeah,
right, okay. Okay, that's us actually. I didn't even realize that it doesn't work. All right, so before we start, a quick introduction about our project. What do we actually do? So we actually developed the global CMS system for Mercedes-Benz for their product pages. What does it mean? So all the links that are here are actually our system. So once you go to www.mercedes-benz co UK, for example, you actually get to the page where you can get information about the cars that Mercedes-Benz builds. You can search for dealerships using the dealer locator, schedule test drive, etc. And by the end of this year, we plan to have our CMS solution deployed to 56 countries. So we are still in the process of rolling out. The original project inception was in 2014. The original development started based on AEM 6.0, and hence it was still on classic UI because of some of the instabilities of Touch back then still. And yeah, we currently run already on 6.3 and are in the process of upgrading to 6.4 and looking forward to see some of the new TouchUI features there. All right, let's talk about our TouchUI migration. So to actually give another deeper context for you about our project is that we started the migration in the beginning of the year. And the project scope, just for you to understand what a large project for us at least is, we have roughly 80+ page components that our content editors can use. We have 140 components that can be used within those pages. And although it's actually hard to count them, we have a rough estimate of 50 customizations, which is, you know, customized XJS component for our current classic UI dialogues. We have overlays for different areas of the system, and we have extensions made for the classic UI-based UI, like site admin, dem admin, site kick, which is all in the scope of our TouchUI migration. Just before we start actually digging further in, we will reduce our scope here to the migration of dialogues. All the principles that we will be talking about still apply to everything else, like wizards, shell pages, etc. But this is more or less due to the time constraints of our talk. All right, Antonio.
Thank you, Gregor. So let's start and see how is TouchUI different from classic UI. In here, we have some examples. First, on the left, we have a classic UI example of a dialogue, and on the right, as you can see, you have a TouchUI example of a dialogue. They pretty much look the same. They have some more or less the same type of tabs, same sort of components. So basically, as much of you much know, UI interfaces in AEM, including components and dialog, are declaratively described by nodes and properties. As we can see here in the example where we have the JCR representation on the left of the classic UI and on the right of TouchUI, we have a similar structure with different node types and different wrapper nodes. So, but underneath it all, things are in fact different. So, but first of all, let's take a step back and understand how classic UI architecture behaves. So UI components are only partially defined, as most of you know, in the repository. What does this mean? It means that dialogues have in fact a corresponding node, but the X types are defined in JavaScript sources. Basically, they are detached, as you are aware, from the dialogue. And how do we and how do the end users see this? So basically, client requests the component definition as a JSON from server. We call it a conceptual pull. And then the client, we call it like a smart client, between quotes, is responsible for dynamically creating UI components using XJS libraries and mechanisms. So let's take a look at this example. On the left, we have XJS dialog with a simple text field and a custom X type. And on the right, we have, let's say, a representation of the JCR repository. And as we said before, we have a detached representation from the dialog and from the client libs. So what we have is basically all nodes, properties, and client libs, as most of you are aware. We have the text field that represents the client lib number 2 and the custom type that represents the client lib number 1, both of them detached from the dialog. And now let's take a look at this sequence diagram. Well, we have the 3 actors that all of you, of course, know well: the browser, the AEM instance, and the JCR repository. So what happens? As we mentioned before, the pull, the conceptual pull, a get occurs to the dialog JSON, which contains a definition. So basically, the browser asks for this to the AEM instance. The AEM instance then is responsible for reading the nodes, using the JCR repository for that. And then a serialized JSON is delivered with a dialog definition from AEM to the browser. And then this, let's call it again, between quotes, smart client, the browser is responsible for rendering the UI and presented it to the end user. Of course, in this case, as we are aware, the onus of this building is on the left, on the browser. And now let's take a look how this is different in TouchUI. So let's start by saying that all TouchUI components are defined in the repository, and every component is in fact a Sling resource. And how we, as end users, or the end users, see these dialogues, for instance, the client requests the page with the UI, and then the server sends the UI as HTML documents using Coral UI HTML5 web components. Again, where before we had a conceptual pull, in this case we call it a conceptual push. So the onus of this is not in the client, is on the server, and the server is responsible in this case for the renderization of the UI and then hand it over to the client. We call it, again, between quotes, as opposite to the smart client, the dumb client with fewer responsibilities. Let's make a parallel to what we saw before. So on the left, we have the TouchUI dialog, and again, on the right, we have the JCR repository representation. Again, the same dialog, the text field, and then our custom component. In this case, as we mentioned before, the thing to retain is that everything is a resource. Every component is a Sling resource. And again, the same parallel. How does this push mechanism work? So again, the same 3 actors: our browser, our AEM instance, and the JCR. So again, a get is made, but in this case, is a get made to the HTML. And then the AEM instance is responsible for using Sling mechanisms, not only resolve the dialogues, but also the components. And then, this is the big difference, is the server that is responsible for the renderization of the UI, and then hands over the UI to the browser. So again, this conceptual push, that's why it is between quotes, this conceptual push occurs, and then the browser is only responsible for laying out the UI to the customer, to the end user. This is just a summary of all the differences. I'm not going to enter in detail because I already mentioned this, and for time purposes, I will proceed. But for future reference, we'll leave this in the slides for you to consult. Let's just mention that the topics covered are, in fact, the dialog nodes, the Sling resources, the JavaScript location, and the event handling. This point will now be covered next. Sorry. And so let's make the parallel between the classic UI event handling and on the next slide, the TouchUI event handling. So as again, most of you are aware, in here this case we have a XJS dialog. The event handling in classic UI is made through listeners and through embedded JavaScript. So we have connection between the imperative part and the declarative part. So as you all must be aware, or should be aware, imagine that we have a load event, a change event, and a submit. What do we do in order to contemplate these events? We hook listeners, in this case 3 listeners, one for the dialog, the first one, and then the text field, and then on the OK to the submit button, we hook listeners. And our JavaScript code is binded to this listener in order to in order to process the changes that we want. In this case, load, again, change, and the submit. Again, one thing that we need to retain is this. The imperative part is, in fact, embedded with the declarative part in one single point. Now comes out the difference. In TouchUI, we have a separation of responsibilities. So this declarative part is on one side, in this case, on the left side, represented by the dialog. So we have our dialog, again, our text field, and our custom component. And on the other side, we have the component client libs, JavaScript code. So the imperative part that should be aware of the events that occur on the dialog. How come? We have points. We have special points where we look for the event observation. So whenever a ready event occurs, or a submit or a change event occurs, we are listening to these events, and then we actuate accordingly. Now let's see, how do we act upon these events? So the event handling implementation in TouchUI, in order to comply with this, you need to create hooking points for observation, either to the usage of Granite IDs or Granite classes. When do we use Granite IDs? Basically, when we uniquely identify components that then will be translated into HTML attributes. So imagine that you have, as before, your submit button. So you hook an ID to your submit button, and then your imperative part, your JavaScript, will be looking at that and then will actuate accordingly. But imagine that you want to apply both behavior to both your previously that I showed, your previously text field and your custom component. Then, in order to do that, you use Granite class that will translate into an HTML class attribute. And in here we have the HTML example. So as an example, we use the Coral UI HTML5 file upload component, and then we have here our ID, so that was translated from our Granite ID. In this case, we use this naming, TouchUI dialog image tab image, and then you have also the Granite class that is translated into HTML as your class. In here, we have all out-of-the-box classes, but if you want to hook a class, this will be the place where you would see your class. And now let's take a look at validation, also an important aspect that you often use, of course. So validation in Classic UI and TouchUI is purely done on the client side. This is the same for both of them. The thing is that the difference is that in Classic UI, you were used to use V-types that can no longer be used. So what do? You use Granite UI Foundation Validation, which was brought in. It's a new mechanism brought in with TouchUI. And this is an example how can you use it. Imagine that you have your validator. We call it uppercase. So what do you do? In your dialog, in your attribute that you now called validation, you just pass your uppercase validator to it. That's called uppercase. And then in your JavaScript, what you do, you have to first attain your registry, your foundation registry, and then in order to use your uppercase validator, you need to register into foundation validation validator your uppercase. And in the selector, in our case, we are looking in the DOM for the data foundation validation attribute, which has the uppercase validator. And then you also have to hook your validation function in order for it to be triggered. In this case, we call it check uppercase, which will receive the element to validate. And the final aspect in validation. It's also possible to combine multiple validations per component in TouchUI, something that you could only do in Classic UI by creating this wrapper, this macro validator, which would contain a combination of your validators. In this case, TouchUI gives us the possibility to have, in this case, for instance, our uppercase that we saw before, and for instance, a max length validator. You just need to comma separate them and then assign them to the validation. Again, as an example, in classic UI, you needed to have this thing. Imagine a V-type called Composite Validation that would contain, as I mentioned before, a set of your validators. And finally, in order to validate mandatory fields, we use this keyword, the required attribute, but in fact, we had some issues with it, which will be tackled further ahead.
All right, thank you. All right, and I'm going to continue to talk about customizations. And so actually, to start, in an ideal world, you would just use the out-of-the-box component, place them into your project, and continue using that in your dialogues, for example. But unfortunately, usually it isn't like that. And what you need to do is customize potentially the out-of-the-box components. And there is a couple of mechanisms out there that allow that, and we want to review them. First mechanism that we want to discuss is a very lightweight mechanism of customization. It's actually not a code-based mechanism. Is the use of granite data, right? So if you use your TouchUI component, an out-of-the-box component, let's say multi-field, and you have some business logic that you want to attach to it, you could actually use the granite data, put your custom attributes in there with your custom values, and use it later when it's rendered on the browser. To make it a little bit simpler, or to give you actually a better context, let's start with an example. Let's say you want to use the multi-field component that comes out of the box, but you actually want to restrict it to a predefined number of elements, right? So the user must only be allowed to enter 4 elements. And how would it look like? So here, in the dialog definition, you create your multi-field object or your multi-field component. You then add a granite data node. And then with the max items, for instance, in this case, you actually add your custom field. This doesn't come out of the box. This is something that we made up, and we assign the value of 4. What happens then when Sling renders that, because again, we've just learned that's a server-side mechanism, when this gets rendered, the HTML that is handed over to the browser will have translated that into data max items, and then the browser can actually retrieve that value. So meaning in the JavaScript side, when it actually handed over after it was handed over to a browser, you can actually get a hold of the reference of the multi-field, and then actually with a data function, just get the value and apply your business logic accordingly, for instance, in the form of the validators that we just talked about. But this is not sufficient for all the use cases. So as we've seen, and as I already mentioned, this is mainly the more simplistic customizations. So what is if you need actually to go further than that, that your business logic is actually more complex or more sophisticated than just adding a couple of custom attributes? So you have basically two additional mechanisms around, and they have been around with AEM for a longer time. These are not new, but we want to discuss it in the context of TouchUI. So one thing is overlaying, and the other one is overriding. Let's briefly remind ourselves of overlaying. What is overlaying is more or less a replacement mechanism, or what we also call it a hiding mechanism. It works both in classic UI and TouchUI. So if you have a component that you want to modify, you actually put your modified sources into the corresponding apps folder, and then essentially you have your custom version out there, with the very obvious downside of actually you have replaced the out-of-the-box or whatever other version you overwrote. So that for existing consumers is no longer available, so now only your code is available, which could potentially be a problem. Also, another aspect of overlaying is that AEM or Adobe restricted actually the possibility to override particular components. So for instance, in AEM 6.4, there's the concept of sustainable upgrades, where particular components are actually explicitly marked not to be overlayable. If you do that, you'll end up with lots of warnings in your logs, so better stay away from it. Okay, so what is at least in our opinion, the better mechanism is the overriding mechanism. And this more adheres to common object-oriented principles of inheritance. And it was around there or possible in Classic UI. So again, Classic UI, everything was performed client-side, as we've learned. And you could actually get an out-of-the-box widget, for example, and extend it using CQX extend and inject your custom code there. That is no longer possible. We are now dealing with a server-side mechanism here in TouchUI. So what we can do is actually take advantage of the Sling resource merger and use the Sling resource supertype attribute, point to the component we want to inherit behavior from, and then actually override it with our custom business logic, for instance. The obvious benefit of the overriding mechanism is very obvious. It's actually the component you're extending from stays as is, so you're not affecting the existing consumers. But in both ways, actually, in our experience for the last couple of months, we see that even if this is a less intrusive mechanism, the overriding, you still need to be aware of incoming changes upstream. So if you do a system update, apply service packs, etc., where your upstream component changes, please be aware of that. Do your testing as usual. All right, just a very quick example how overriding works. So a use case is there's actually a real life use case, right? So we are back to multi-field. I'm going to explain in a second why we did that. But here we actually wanted to create a custom version of the multi-field component. The original out-of-the-box version, Granite UI multi-field, is there with its main Sling rendering script. And on the right, there is our custom version. What we wanted to do is to change the persistence mechanism. So what we do here, we set up our own component with our own namespace, Daimler UI multi-field, use the resource supertype, point to where we want to inherit behavior from, and override it here. All right, let's talk about the general migration approach that we took, or that are possible, and we found interesting. So regarding the user interfaces, Classic and TouchUI, the benefit or the advantage what you can take is that you can actually use both UIs in parallel, right? So you can use Classic UI at the same time. You can use TouchUI if you make things accordingly, or properly, sorry. And what does it mean? It means that you can actually introduce your migrated TouchUI changes in stages or per your development iterations without actually affecting any of your production users that are still working with the old interface. That also actually extends the testing window that you have, meaning that you don't have to migrate everything at the end of your migration, which might take, I don't know, several iterations. You don't have to test it at the very end. You actually can introduce those changes all the time, have it tested. And the benefit from a development perspective is that you don't have to engage in any complex branch tracking, merging, etc. It's actually, you just can actually implement all your TouchUI related code on your main development stream and have it rolled out into your production system. Another benefit, at least in our particular environment, is that due to being able to run these two UIs in parallel is that we can also stage our trainings also in batches to our international user base. So we don't need to switch all of our content authoring users at once. We can do it one at a time once we are finished with the migration. All right, but how can you achieve that? I mean, there's a couple of things you need to be aware of. So it's not as simple as, okay, it always just works in TouchUI and you can always run in parallel. Let's talk about data structure. So what do you need to be aware of in order to prevent this big bang data migration where you actually need to switch at some point in time and be able to do this, as we just said, in iterations? You need to retain compatibility or backwards compatibility to your previous data structures. What does it mean more explicitly? All of the code that you have in Classic UI and all the components, they are storing the data in a predefined structure. And potentially the TouchUI equivalent, or whatever you come up with, might expect a different structure. One prominent example is, for instance, the multi-field in Classic UI. There was a multi-field available that used to persist all the items in a JSON-like data structure, or the individual item that users added. TouchUI now comes with an out-of-the-box multi-field component that unfortunately does not support the JSON-like data structure. It actually stores or persists the items in nodes, properties, and arrays. So what do you need to do here is essentially use the same mechanism that we said, like we talked about with the overriding example, override the upstream of the out-of-the-box multi-field, and then inject your code there that can still deal with the previous JSON-like data structure that is expected by classic UI. Once you do that, you will be always able to switch back and forth between both UIs, which we found, again, in our environment quite interesting or quite useful. All right, one final aspect to consider and that we worked on quite a while is the management of JavaScript code. So both UIs bring their own JavaScript code, obviously. You might also have components around that do use some JavaScript code, v-types, etc., as we've learned. And now you need to have your TouchUI versions equivalents of that. And actually, our recommendation is to just really separate both of these JavaScript files, meaning that separate them and manage them in separate client libraries. Why is it so important? First of all, you're going to avoid all the mess with some conditional statements where you say, okay, if I'm now running in Classic, then I do this, otherwise that. That will be actually very hard to clean up at the end. So once you perform the migration or completed it, you will have another iteration where you need to remove everything. So actually, just place it parallel to the existing client libraries, put your TouchUI code there. And there is one particular problem that we want to point out. We actually ran into that. Although we have cleanly separated that, we also identified that we had classic UI client libraries that obviously, because they're created in a time where only Classic was around and only Classic was used, they assume a particular context. They assume they are always running in Classic UI. And this might lead to problems if those scripts get rendered in the TouchUI interface. And how could this happen? It could potentially happen because TouchUI retains a so-called compatibility mode. In that mode, it's still able, if you still have no TouchUI dialogues converted for your components, TouchUI will actually display the XJS-based dialog that was set up before, meaning that it will drag in the client libraries for Classic UI. And in this particular use case, you are prone that your existing code that assumes the wrong context might potentially break. So again, just to summarize it, separate client libraries, and to avoid what I just said, the second use case of assuming the wrong context, what we did is actually we placed some safeguards around some of the previous XJS-based code, where we actually first check if we are running in the right context. If we do, we invoke it, otherwise we stay away from it. It's actually a simple conditional statement that you could put as a safeguard around your code. All right, let's talk about some of the recommendations and best practices that we identified throughout our project. And yeah, I mean, some of this is pretty obvious, but what we have found, in our new developer group, when we started or engaged on this project, we actually would recommend start with the simplest components that you have around. What does it mean? Potentially you have some text fields or similar that doesn't have any JavaScript code, potentially no validators, meaning v-types in Classic, or doesn't have any custom client libraries. Start with them, get a feeling, how does TouchUI look and feel, how can you work with that, and then just gradually try to implement or migrate the components that are more sophisticated. One thing to note here is also there's a tool around which is called AEM Dialog Conversion Tool. We used that in the very beginning. Is actually you throw a Classic UI dialog definition at it, and what you receive back is what's supposed to be the TouchUI equivalent of that. But yeah, what we saw is that it has some limited functionality. It will not give you the opportunity that you just give all of your TouchUI dialogues there and you will retrieve everything in the correct format. It breaks at some points, but we still think that it's a great tool to get you started, to bootstrap your effort, and to play around with TouchUI. a couple of other recommendations really quick is that what you should avoid is actually the use of Coral2 components. Coral2 components are soon to be deprecated. So if you want to avoid another migration after you completed the TouchUI migration, stay away from Coral2. How can you identify Coral2 components? It's actually pretty simple. We provided here 2 examples, right? The Coral2 version of a text field and the Coral3 version of a text field. And the difference is how you identify it. It follows the same pattern. So between the components path part and foundation, there is the Coral path piece. And if you see it in your dialog definition where you set up your component, if you see Coral there, you're using the right one. If you don't have it there, stay away from it and look for the equivalent. But it goes a little bit further than that. You also should avoid the use of Coral3 deprecated components. There are some components that get deprecated over time. The most prominent example of such a component is the path browser, which is quite a useful component for browsing through a repository with a path picker. It was deprecated with AEM 6.3. Here, actually, we don't have that easy pattern that we could actually just see if path elements exist or not. Here, actually, we would advise that you actually check the release notes of every AEM release or service pack and see if some of the components have been deprecated, right? So again, in order to avoid any further migration efforts. And also, what we also slightly mentioned before, but I want to repeat that, be aware that the components that get shipped out of the box change over time. So if you have customizations out there, we, for instance, had like the asset details page recently customized. Although it's not a standalone component as is, it's a composite of components, but some of the components have changed with a service pack installation, meaning that we needed to do adaptations. But I guess it goes without saying that if you do such upgrades to your system, you should have a good test plan in place. But I think the best thing is, again, check the release notes. All right, and I think, yeah, we're almost running out of time, but just to conclude our talk, a couple of pain points, or maybe put in more positive words, some room for improvement, what we have identified along the way. It's definitely not a comprehensive list. It's just more or less for, if some of you guys haven't yet migrated TouchUI, just to give you a couple of things, to consider and see what you could potentially be facing. So in the beginning of a migration, we very early on identified that, for instance, the rich text component in TouchUI has some severe or has some issues. Rich text being, at least in our system, one of the commonly or very, very often used component for our content authors. It actually had issues regarding the validation, which we were able to work around. But it still has various rendering issues, which are, at least in our international context, we wouldn't be able to actually roll it out like that. So we went through the usual support channels, and we are trying to get this fixed with the help of support and engineering. Same goes to the use, like another example would be the use of sling hide resource. That's one of the resource merger mechanisms. What you can do with that, actually, if you get something upstream, if you inherit from something, you can hide or remove particular properties, right? We use that, for example, in the page properties, where we want to remove some tabs from an out-of-the-box page, but that actually causes the MSM relationship or inheritance logs to disappear. We are currently working on a solution here as well. And last but not least, we were running into several layout problems in the past. For instance, we had like tooltips on our dialogues. You can actually add them, I think, to each component that you have laid out on your TouchUI dialog. You add a tooltip where there's some information, helpful information or is supposed to be helpful information for the user. Unfortunately, when that gets rendered on the browser, it actually overflows outside the frame of the dialog and is hidden. So not so useful for the user, actually. we actually were pretty simple there was a pretty simple way to fix that. What we did, we created an overlay, but as we said before, unfortunately, creating that overlay, we're creating an overlay for an out-of-the-box component that must not be overlaid. Again, in 6.4 with sustainable upgrades, these situations will become clearer to identify. If you have a problem like that, go through the support channel and try to get it fixed. All right, I think this concludes our talk at this point. Thank you very much for listening in.
Thank you.
We hope it was interesting.
Yep, definitely.
Any questions? I guess everyone is. Ah, there's one here. No.
Hi guys. I have a question. What the level of automation did you have during the migration? I mean, you said that you've used a direct conversion tool. What else did you have, or did you do everything by hand? And additionally, how did you ensure what you've done is correct? I mean, testing of the migration. Did you do it like with any certain level of automation, or did you do it by feedback of content editors, for example?
All right, so I'm not a test engineer, and I'm also don't know all the processes that they laid out. But first, regarding the automation. So as I mentioned, we used this conversion tool in the beginning, but again, with more sophisticated dialogues, it doesn't really work. So we actually, once we went through this round of playing around with that tool, having some generated converted dialogues, we actually started to just reuse parts of the XML. It's actually the fastest, in our opinion, than using some tool there, and we made good progress with that. Regarding the testing, again, I'm not a test engineer. We have test automation set up, but to be honest, I don't know the specific products that they are using. But we have a couple of colleagues here, also from Mercedes-Benz I/O. You will identify them. They are all wearing this branded MBIO T-shirts, right? So come to us, speak to us maybe after the talk or during a break, and maybe also my colleagues could give you more details about testing.
Okay, thank you.
All right, sure. Yeah, sure.
Did you make this multi-field JSON available, open source, or?
we didn't. You're interested in that? Yeah, it's actually pretty simple. If you want to, we can just look at this. We have the code here. There's nothing really that we want to hide or something like that. Let's talk after the talk, right?
Hi, I just have a question regarding the CQ listener nodes. Did you do anything specific to the CQ listener nodes that are there for the classic UI? Because it refers to some objects that are very specific to the classic UI. So did you do anything specific to convert to reference those objects for the TouchUI?
Okay, I can explain that.
All right, go ahead.
Where we before had the classic UI approach now, in TouchUI, what we did, in fact, was use the IDs of the elements, so add attribute, use the Granite ID attribute, and with that, we listen to the behavior changes, so we hook through JavaScript, we hook to the event listener, as the previous event listener that we had in classic UI. In this case, we hook JavaScript code to this ID, and we listen to the events on this element. So for instance, if you have a text field and you identify it with the ID, with the Granite ID in this case, so in your JavaScript, you can, using JavaScript, of course, check, for instance, the onload event or onChange event, if, for instance, you have this text field when you're typing, and then with that, you can produce your validation. I don't know if I was clear enough.
Yeah, that part was clear. So I think, but anyways, the code has to be completely rewritten because the objects that are referenced inside the JavaScript are mostly very specific to the classic UI. So for the TouchUI, it requires a different set of code itself, very specific to it. Once you listen to those events, let's say it's a refresh event or something like that, then you have to completely rewrite the code for the TouchUI as well. with those specific objects that we are using for the classic UI.
I see what you mean. So you can, I think you're asking about the reusable of the code, right?
Yeah.
Okay, yeah. In fact, the JavaScript code that is embedded in classic UI, most of it, we reused it in TouchUI, but not the same way, as I mentioned before. So as the event handling is hooked to these hooking points, as we showed before, either through the Granite ID or to the Granite class, the code can be, now is detached from the dialog, as we previously mentioned. So you have your JavaScript file, in this case, and you can reuse it, in fact, but not on the same way. So you have to extract your imperative part, your JavaScript part, from your dialog, and then place it on a separate JavaScript. And then, again, with the event handling, you can hook in.
Thank you.
I think to summarize that, you're using mechanisms that are closer to vanilla HTML
exactly.
and not so much close to
XJS. Yeah, exactly.
Did you also consider to change from JSPs to HTML while migrating from Classic to Touch, or did you have like some pros and cons you thought of?
Yeah. So to be honest, we don't have any JSP code. I mean, maybe some minimal somewhere to bridge something, or overlay something in the system. But in our actual implementation, we use HTML, and that is kind of detached from from the aspect of using either Classic UI or Touch UI.
There's one last question on the right-hand side, and then I would move on.
Yeah, sure. Yeah.
More a suggestion rather than a question. So I really like the content classification in AEM 6.4. I think that would be great to leverage also to deprecate components, because you can automatically leverage that through tools, and you can automatically code or write code
identify automatically what is deprecated. This is what you mean, right?
Exactly.
Yeah, that's what I said. You cannot follow always that pattern. Yeah, that would be actually a great idea. Similar to what we have with sustainable upgrades, if we had something like that just for components. I agree.
Okay. Well, thank you very much for the presentation.
Thank you.
If there are any more questions, as we're close before lunchtime, there's one appetizer for lunch actually coming up on stage for a couple of minutes. But before, if there are any more questions, you may get to Mercedes-Benz I/O while it's lunch. As they're our sponsors for today's lunch, it's perfectly suiting and fitting. Okay, thank you very much, Antonio and Gregor.
Thank you.